Hi everybody. We're going to do the first problem that we did in Wednesday's class, just to give you a feel for what's going on. And I'm going to throw in a couple of extra commands just for your own viewing pleasure. And let's go ahead and start with the first command. We're in R, and we're in the handout page, and we're going to start out with library QCC, and that brings up the quality control piece. Alright, then we have to get our library, our data file and our library. So let's go into Blackboard. Where's Blackboard? Here it is. Okay, and scroll down to 4300. I've got a bunch of classes, so don't worry about that. So you're in 4300, go to Discussions, go to Data Sets, and go to Data for 925 Part 1. And I'm going to save this file. I'm going to right-click on it, and I'm going to say Save Target As, and I'm going to put, let's just leave it as it is. It's in Computer Local Disk S4300. Okay? Now, you can put yours in the desktop wherever you want to. But remember what directory it's in. Now let's go back to R. Remember, we have to change the directory to get our file. So let's click on File, Change Directory, and then we're going to go to local disk, and in this one we had stat 4300, so scroll down through there. There it is, S4300 actually. Click on that and say OK. So now if we look at our Get Working directory, we'll see we have the one that we wanted. Okay, now let's take another look at our handout. So we need to bring in the file. So we're going to copy if we can. Alright, so we're going to put in xe1 assigns read.table file equals xe1.text in quotes, header equal false. Okay, now if you're wondering what that file looks like, this is very interesting. You can put in a command called file.show and put in the file name, and that way you can see what the data set looks like in case you were wondering. So here you've got the number that the sample is in. Here's the actual data. So you can see 1, 2, 3, 4, 5 are in group 1. 1, 2, 3, 4, 5 are in group 2, and so on. Then you just close that out. Don't hit the red X, hit the little blue X. Okay, and that gets you back to where you want to be. That's just something I like to do periodically. Okay, so if you notice, we have no headers on the file. We don't have names on the variables, so we want to put them on there to follow a special pattern, and we're going to call these sample and data. Okay. Whoops. So this is going to be names of xe1. So you have the names of the data frame are equal to C of sample. So the first column has the name sample. The second column has the name data, which is what we want. Okay. Now we're going to go into the actual library QCC and pull some commands out of there. And we have xe1.group assigns QCC groups and that's XE1 $data. So you remember we just put the name in data, and then we have XE1 $sample. Whenever you have a data frame with names, you can always use the data frame name, $, and then the name of the column. So if you want to see now what that data frame XE1.group looks like, you put in head XE1.group. Aha. So now, instead of being vertical, this is now in horizontal in groups, which is as we want it to be. Okay, then the next one is to produce our X-bar chart. And I'll put the command back up in a second. And here's our chart. And we have our number of groups. We had 25. There's our center. There's our standard deviation. We have a lower control limit, an upper control limit, and our process is in control. So you notice that the number beyond limits and the number of violating runs is 0. So I'm going to close that out. And let's just look at the command again. You just put in XE1.group. That's the name of the object we just created, and we want an X-bar chart. Okay? Now we also need to save that. Not only do we need to plot it, we need to save it to an object for our next command. That is the OC curves, and that's going to give you your operating characteristic curves. Ooh, aren't those pretty? Okay, so on this you notice there are different values of n and different types of lines depending on what you're using. So as you see, as you move in, as your n increases, your lines get closer and closer, and the beta value diminishes, which is what you want. So let's close that out. Now here's another one that I didn't put on there, but it's lots of fun. If I would have put OC.curves of Q and then put in identify equals true, now when I go back over to the chart, my cursor appears as a plus sign. So I can click on these lines and it will give me what the C value is. The C is the shift that comes across the bottom, the beta value, and the ARL value. And we'll talk more about the ARL in another video that I'm going to put up in just a few minutes. So here's my N of 5. Okay, that means that the horizontal value is 1.4, the beta is 0.4925, and the ARL is 2. Okay, and let's just do another one just for fun. So you've got C1 is equal to 1.1, the beta is 0.3161, and the ARL is 1.5. Now to get out of this, you right click, you hit stop, and it turns you back to the console. Okay, it also shows you which values you clicked on. Alright, so we're saving our beta in another object. Okay, and that's the little noise you hear is my dryer. So we're saving that in an object, as I mentioned. Now I want to print my beta and see what's going on in there. And I'm rounding it to 4 places to the right of the decimal. That's what the round beta comma 4 refers to. Okay, let's take a look at this. Let's scroll up a little bit. Alright, so on the extreme left-hand column is your shift, your standard deviation. On the chart, that's what appears on the horizontal line. Then you've got n equal 5 n equal 1, n equal 10, n equal 15, and n equal 20. The values in the center are your beta values. Now, you're going to see as we scroll down here, let's just say for argument, I'm looking for beta equals 0.10. So, how much of a shift do I need in the n equal to 5? So that's going to be the 1059. My shift is at 1.9. Okay? Alright, how much for n equal to 1, which is the next one over? Wow. Keep scrolling. Okay, you've got your 1056, and that shift has to be at 425. Alright? Let's scroll up. Let's just do n equal to 20 just for fun. And I want to get beta of 0.1. Oops. Where'd you go? It's pretty good, actually. And that's your 1059. So your shift is only 0.95. Okay, so you can see as n increases, the shift level is decreasing, which is as it should be. And typically you want to have a beta around 0.1, if at all possible. Okay? Then the last thing we're going to do is process capability, and on that you'll use your object that you created for the quality control chart, the X-bar chart, and you have specification limits, and I will always give you the specification limits, so don't worry about them. Oops, sorry. Let's go back and get that bad boy. Alright, let's try it again. Okay, so on this one, you've got a target, which is your center, close to your center, and then you've got your lower specification limit, upper specification limit, a histogram, and essentially a probability density function. On this one, your process capability is 1. The lower limit, excuse me, they did it in reverse. That should be your upper limit is 1.71. Geez, that's weird. Okay, 0.294. And on this one, your expected value greater than USL is 19%. Your observed minus USL is 17%. Wow. Not so good. Okay. Well, anyhow, that's how it works. That's what's going on. Hope it helps.